Good evening to all. So today we are going to continue about the chiller system. You know that why we are using the chiller system in our air conditioning application, so that a commercial, industrial, and high capacity system. Always we are going to select the chiller system, either air cooled or water cooled, based on water quality and location. Here, the design considerations in chilled water plant, the chiller efficiency rating as per ASRAE 90.1 standard provides minimum efficiency standards for water chillers. The standard chiller ratings are based on AHRI, that means Air Conditioning Heating Refrigeration Institute standards 550, 560, and 590. What are the parameters needs to consider for the chilled water plant design? First, as per AHRI test conditions, the leaving chilled water temperature is 44 degrees Fahrenheit, that means 6.6 degrees Celsius. You know the chilled water leaving temperature little bit vary based on the climate. Summer, monsoon, winter, the seasons are there, no? Accordingly, this temperature little bit vary, not accurate. Okay. Next, the evaporated water flow rate has to be calculated using of that formula Q equal to mCp delta T. Q is nothing but a volume of Q is nothing but a capacity in BTU per hour, which is calculated in heat load calculation. Then that mCp is mass into specific heat of water into delta T should be in degree Fahrenheit. Use this formula to calculate the water flow rate, how much need to cool the air. So this formula used to find 2.4 US GPM, that means US gallons per minute per TR. Its record when the delta T at 10 degree Fahrenheit. That means 9.084 liter per minute per ton. If you are calculating the ton of refrigeration using of the HVAC software or using of Excel sheet, based on the ton of refrigeration, directly you can calculate the water flow rate using of this 2.4 US GPM per ton, or if you are going with the SI units, then you can take it 9.084 liter per minute per TR. Then entering condenser water temperature, if it is water cooled chiller, then the condenser water also required. This water is coming from the cooling tower. So the entering condenser water temperature around 85 degree Fahrenheit. This also little bit vary based on the location and bed bulb temperature, ambient bed bulb temperature. So this water flow rate also is calculated by using of that formula Q equal to mCp delta T. Here we are considering as per CTA standard 25% higher than the chilled water flow rate. That means generally we are taking that unit conversion 1 TR equal to 12,000 BTU per hour. For this condenser water, that is a normal water. No? That's why as per CTA standard, we are going to take 25% higher. That means here we are considering 1 TR equal to 15,000 BTU per hour for this condenser water flow calculation alone. Okay. So same formula we are going to use 3 EH GPM per ton or 11.35 liter per minute per ton. Next, the condenser water flow rate for absorption chiller. Previous one is compression system, the vapor combustion refrigeration system. Here, this is the vapor absorption refrigeration system. You know that vapor absorption system, generally we are selecting where that steam is available. For that project, we are going with absorption chiller. Mostly, this absorption system may will come paper mill, that kind of industries. Okay, so we are not going to propose any boiler and all. Is there available in boiler with steam? Then we are going with absorption chiller. So if you are going to select the absorption chiller, then the condenser water flow rate 3.6 to 4.5 GPM per TR, 30.6 to 17 liter per minute per TR. So this much is required for the vapor absorption refrigeration system. Then ambient air for the air cooled chiller, when it is 95 degree Fahrenheit, that means 35 degrees Celsius is available. So these are all the test conditions for the AHRS standard. Last class we studied that capacity and what is the power consumption of the chiller, what are the compressor we are going to use. That and all we are studied in that last class. Now we are seeing about the design consideration in chilled water plants. So these values you have to keep in your knowledge and implement, do in your projects uh, with effectively. Okay, so generally in the chilled water system, the water quality is going to check. That means that pH level. Okay, last class itself I told seasource area, water demand area. Generally, you go to select the air cooled chiller. Why? Because the seasource area, the water quality is poor. You know that that water is having salty. So that water cooled condenser, that is a selective condenser. The water is flowing through the inside the tube. That means if you are selecting that water cooled chiller, what will happen? The salt formation is happening in the inside the tube. So that descaling is a very big cleaning process. Okay, that's why that kind of area we are going to select the air cooled chill. So that's all about today. So same chiller process will continue on tomorrow. Thank you all.